All right, let's look at the homework 3.7, problem number 5. All right, so we have piecewise defined function, and we want to answer these questions. All right, so let's do that. All right, let's find the x-intercept. All right, so we set the y equals 0. All right, so if you set this guy equal to 0, but realize that x squared plus 2 is never 0, so we don't have anything there. But if you set 2 minus x equal to 0, we can see that x equals 2. So x-intercept would be at 2, comma, 0. And make sure that the x is 2, x is greater than equal to 0. So 2 is greater than equal to 0, so that works out. So that's the x-intercept. And a y-intercept, so we set x equal to 0. But here you can see that x belongs to the, here, x equals 0. So we have to use the second formula and plug in 0 for x. So you have a 2 minus 0, so it's going to be 2. So 0 comma 2. All right, so that's the y-intercept. All right, let's check the answer first. All right, it came back and looks like we got intercepts correctly. All right, so let's find the relative maximum and the relative minimum. All right, so easiest way would be probably just sketch the picture first here. If you draw x squared plus 2, so this is just going to be a parabola, and plus 2 will shift it upward 2 units. Right, so that's on the negative side. Right, so who would have that? Right, so this one looks okay, and here this one's not, so we eliminate the second picture, and we can actually eliminate the third picture and the fourth picture because this is pointing downward, but we have x squared plus 2. It's a parabola facing upward, so this is the only picture here. All right, then does this guy have a relative minimum? And you can see that there's no relative minimum, right? So we can say does not exist, right? Actually, so that was a relative maximum. Same answer, does not exist there. And so both relative max and relative min, we have does not exist as the answer. All right. Point of inflection. All right. So concavity here is positive. I mean the concave up. This is straight line, so there is no. It's not concave up or it's not concave down. And there's no tangent line there, so this cannot be an inflection point. So it looks like there's no inflection point either, so it does not exist. All right. Horizontal asymptote. You can see that the graph is keep on going down. It does not get close to any particular number. There is no vertical asymptote. It does not blow up at any point, so it's actually does not exist again for both of them. Does not exist. All right, and we have the picture. So let's check the answer here. All right, it came back, and looks like you know why this problem wasn't all that interesting, because a lot of things do not exist, but these are the correct answers, and we have the correct picture as well. All right, that's it. I hope that this was clear.